Imagine standing on the barren surface of the moon, looking out over the vast gray and white. Suddenly you notice something strange, swirling patterns stretching across the lunar landscape that seem much brighter than the surrounding landscape. These mysterious features, known as lunar eddies, have puzzled scientists for decades. What could create these confusing features? The answer may lie deep beneath the moon's surface, where subterranean magma and magnetic anomalies tell tales of cosmic intrigue. What are lunar eddies? Lunar vortices are strange winding features on the surface of the moon characterized by their light and reflective appearance. These formations can stretch for hundreds of kilometers, creating intricate patterns that stand out sharply against the darker lunar landscape. Despite their distinctive appearance, the exact origin and process of formation of the moon's swirls remained unclear. Lunar eddies are more than just a visual curiosity. They are a window into the moon's geological past and hold secrets that could change our understanding of the moon's history. Despite many missions to the moon, no astronaut has ever set foot on these strange formations. Instead, scientists relied on images, measurements of the magnetic field, and analogs on Earth to piece together the puzzle. In the latest twist to this scientific mystery, planetary scientists have proposed a groundbreaking theory that links these eddies to subsurface magmas and their interaction with magnetic fields. The first observations of lunar vortices date back to the early days of lunar exploration. Images taken by telescopes and later lunar missions revealed these strange markings. Early lunar explorers and scientists speculated about their origin, but without direct samples or detailed information, these features remained a fascinating mystery. Over the years, several theories have been proposed to explain the formation of vortices on the moon. Some scientists suggested they could be caused by meteorite impacts, while others thought they could be related to volcanic activity or even remnants of ancient magnetic fields. Each theory brought a new perspective, but also raised more questions. One of the earliest theories suggested that the moon's eddies were created by a meteorite impact. Meteorites bombarding the lunar surface can deposit iron-rich material that can cause magnetic anomalies. These fields can then affect the distribution of lunar dust, causing vortices to form. Michael J. Kroksinski, St. Louis, an associate professor of Earth, Environmental and Planetary Sciences at Washington University, has studied the theory extensively. Kroksinski noted that meteorites provide iron-rich material to the lunar surface. At the same time, he noticed that lunar vortices form in regions that may not be disturbed by meteorites. This finding suggested that while influences may play a role, they may not be the sole cause of these enigmatic traits. Kroksinski and graduate student Yuanyuan Liang proposed an alternative theory for underground magma. According to their hypothesis, lava slowly cooling in the magnetic field underground could cause the magnetic anomalies associated with the moon's vortices. This theory provided a new perspective on the formation of these features by linking them to the moon's volcanic past. To test this hypothesis, Kroksinski and Liang designed experiments to measure the effects of different air chemistry and magmatic cooling rates on a mineral called ilmenite. Ilmenite, a titanium oxide mineral, has a weak magnetic signal but is common on the moon. The purpose of these experiments was to determine if the cooling of underground lava could create the magnetic anomalies necessary to produce vortices on the moon. The results of these experiments were promising. They found that under certain conditions, cooling underground lavas can indeed produce magnetizable material. This discovery suggested that subsurface magma may be responsible for the formation of eddies on the moon, providing a plausible explanation for these mysterious features. Despite the lack of direct lunar samples, planetary scientists have used terrestrial analogs for lunar rocks to understand lunar magnetism. Minerals that often contain small particles of magnetite, a magnetic mineral, are easily magnetized. However, the moon lacks this hypermagnetic mineral, forcing scientists to find suitable substitutes. The research team used ilmenite, a titanium oxide mineral with a weak magnetic signal. Ilmenite is ubiquitous on the moon and readily reacts to form magnetizable iron particles. This mineral became the focus of these experiments, providing an important link between the geology of the Earth and conditions on the moon. Definitely, here is an extended continuation of the study of lunar vortices and their wider implications. The mystery of lunar vortices continues to fascinate scientists and space enthusiasts, drawing attention not only to their striking appearance, but also to the deep questions they raise about the moon's geological and magnetic history. By unraveling the mysteries of these formations, we are paving the way for future studies and discoveries that promise to deepen our understanding of both the moon and the wider cosmos. Each new discovery in the study of lunar vortices brings us closer to unraveling the complex and dynamic nature of our celestial neighbor. These eddies, with their pale, jagged patterns, suggest processes that may have been at work billions of years ago, shaping the moon's surface in ways that are not yet fully understood. By elucidating the mechanisms of their formation, whether through underground magmas, magnetic anomalies, or other geological processes, we gain knowledge not only about the geology of the moon, but also about the formation and evolution of planets throughout the solar system. Additionally, the study of lunar vortices has implications beyond our immediate lunar interests. Understanding the role of magnetic fields and volcanic activity on the moon provides important benchmarks for studying other planetary bodies, such as Mars and Mercury, where similar processes may have shaped their surfaces. By studying these relationships, scientists can build a more comprehensive understanding of how planets and moons evolve under different environmental conditions. In addition, the study of lunar vortices inspires future missions and technological development. Projects like NASA's Lunar Vertex mission, which aims to study the magnetic properties of vortices like Reiner Gamma, are important steps in our quest for deeper lunar knowledge. The purpose of such missions is not only to confirm assumptions about the formation of the lunar vortex, but also to pave the way for more ambitious endeavors such as human exploration and possible colonization efforts. In experiments conducted by Krasinski and Liang, ilmenite was subjected to various atmospheric chemical effects and cooling rates. They found that the smaller ilmenite grains produced stronger fields because of their greater surface-to-volume ratio. This finding was consistent with observations of similar reactions in lunar meteorites and Apollo flight samples, which often contained magnetizable iron particles. Analogous experiments have shown that it is possible to create magnetizable material under lunar conditions, which is necessary for the formation of lunar vortices. This finding supported the hypothesis that subterranean magma cooling slowly in the magnetic field could be responsible for these puzzling properties. But for this process to happen, the underground magma had to have a high titanium content. Discovering this process has important implications for our understanding of lunar geology. This suggests that the volcanic activity and magnetic properties of the moon are more complex than previously thought. By studying these eddies, scientists gain insight into the moon's magnetic history and the processes that shaped its surface. While current technology limits our ability to directly study subsurface rocks on the moon, Krasinski and Liang's research offers a promising method for remotely testing the subsurface magma theory. Future lunar missions, such as NASA's Lunar Vertex rover project, aim to study vortices like Reiner Gamma in more detail. Launched this year, the Lunar Vertex mission is part of NASA's larger plan to return to the moon later this decade. The purpose of the mission is to study the magnetic properties of the moon's vortices and find out if they are really related to underground magma. If successful, this mission could provide direct evidence to support the underground magma hypothesis. The Lunar Vertex mission is just the beginning. Future missions may include drilling into the lunar surface to obtain samples of underground rocks. These samples could provide definitive evidence of the processes that created the lunar vortices and provide a deeper understanding of the geological history of the moon. Lunar vortices are more than just an exciting feature. They hold important clues about the moon's history. By studying these formations, scientists learn about the moon's volcanic activity, magnetic properties, and the processes that shaped its surface over billions of years. The study of lunar vortices also has broader implications for planetary science. This highlights the importance of understanding magnetic anomalies and their role in shaping planetary surfaces. Observations from the Lunar Vortex study can be useful studies of other celestial bodies, including Mars and other moons of our solar system. The mystery of lunar vortices continues to fascinate scientists and space enthusiasts. By unraveling the mysteries of these formations, we are paving the way for future exploration and discovery. Each new discovery brings us closer to understanding the complex and dynamic nature of our moon and the wider cosmos. The journey to discover the truth behind the eddies of the moon is a testament to human curiosity and the relentless pursuit of knowledge. From the early days of lunar exploration to modern-day experiments, Scientists have made remarkable progress in understanding these enigmatic features. Research by Michael J. Kroksinski, Yuanyuan Liang, and others has brought us closer to solving this cosmic mystery by revealing the complex interaction of subsurface magma and magnetic fields. Looking to the future, missions like Lunar Vertex promise new discoveries and deeper insights into the geological history of the Moon. Studying lunar eddies is not just about understanding their special formations. It's about discovering the secrets of the Moon and ultimately the universe itself. The mystery of lunar vortices remains one of the most fascinating mysteries in planetary science, and with each new discovery we take a step closer to unraveling the mystery of the Moon.